Good afternoon. We are going to discuss about the classification and characteristics of memory devices, which are very important part in the computer. A memory is just like a human brain. It is used to store data and instruction. Computer memory is the storage space in computer where data is to be processed and instructions required for processing and stored. The memory is divided into large number of small parts. Each part is called a cell. Each location or cell has a unique address which varies from 0 to memory size -1. For example, if computer has 64 kilobytes of data or words, then this memory unit has 64 into 1024, which is equal to 65,536 memory locations. The address of these locations varies from 0 to 65,535. Memory is the most essential element of a computing system because without it, computer cannot perform single tasks. Memory is primarily of two types: internal memory, which is also known as the cache memory, and primary or main memory. External memory, magnetic disk, optical disk, or secondary memory, which is called the external memory. Now, coming to the basic CPU registers. CPU register, cache memory, main memory, magnetic memory, optical disk, and magnetic tape. So here, basically the total memory is divided into internal memory and external memory. The internal memory is CPU registers, cache memory, and main memory. And external memory is connected magnetic disk, optical disk, and magnetic tape, which they comes under the external memory. The speed increases as the is more for the internal memory and less speed for external memory. The internal memory is basically made up of solid state, and whereas the magnetic disk and optical disks are of different types. Where the magnetic disk as the memory will be stored in the using the magnetic field, and optical disk on the CD, that is on the plastic device. So optical illumination uh, stores in that as a laser dot, and magnetic tape also just like the recording on the magnetic material. Hierarchy are following when we go up from top to bottom. Capacity in terms of storage increases as per the access of the memory by CPU decreases, access time by CPU increases. Now, the primary memory is again divided into two types, RAM and ROM. The types of memory: RAM, random access memory, and SRAM and DRAM. This SRAM is the static random access memory, and where DRAM is known as a dynamic random access memory. And the other type is a read-only memory, which will be having again divided into three: PROM, EPROM, and E2-PROM or EEPROM. PROM is the programmable read-only memory. EPROM is electrically programmable read-only memory, and E2-PROM are electrically erasable programmable read-only memory. So these are the solid-state memories. And a RAM constitutes the internal memory of the CPU for storage data, program and program result. It is read or write memory. It is called random access memory since access time in RAM is independent of the address to the word, that is each storage location inside the memory is as easy to reach as other local and take the same amount of time. We can reach it into the memory at random and extremely fast, but can also be quite expensive. RAM is volatile, that is, data stored in it is lost when we switch off the computer or if there is a power failure. Hence, a backup uninterrupted power supply system is often used with computers. RAM is small, both in terms of its physical size and in the amount of data it can hold. Again, RAM is of 2 times as we have seen in the block diagram. The static RAM, that is SRAM or dynamic RAM. Now coming to discussing about the static RAMs, the word static indicates that the memory retains its contents as long as power remains applied. However, data is lost when the power gets down due to volatile nature. SRAM chips use a matrix of 6 transistors and no capacitors. Transistors do not require power to prevent leakage, so SRAM need not have to be refreshed on a regular basis. Because of the extra space in the matrix, SRAM uses more chips than DRAM for the same amount of storage space, thus making the manufacturing costs higher. Static RAM is used as a cache memory, needs to be very fast and small. And coming to the dynamic RAM, DRAM, unlike SRAM, must be continuously refreshed in order to for its maintain the data. This is done by placing the memory on a refresh circuit that rewrites the data several hundred times per second. DRAM is used for most systems memory because it is cheap and small. All DRAMs are made up of memory cells. These cells are composed of one capacitor and one transistor. Now, the differences between these two random access memories. The DRAM is uh, constructed by tiny capacitors that leak electricity, constructed, whereas SRAM constructed of circuits similar to D flip-flops. So here, this is made up of capacitors and this is solid-state devices, D flip-flops and so on. Then second point, coming to second point, requires a recharge every few milliseconds to maintain its data. Its hold, and whereas SRAM holds its contents as long as power is available. DRAMs are inexpensive and SRAMs are expensive. And SRAMs are these DRAMs are slower, and whereas SRAMs are faster. The DRAMs can store many bits per chip. The SRAM cannot store many bits per chips. Whereas DRAM uses less power and whereas SRAM needs more power. And DRAM generates less heat, whereas SRAMs generates more heat. And DRAM used for main memory, and whereas SRAMs are used for cache memory. Now coming to the read-only memories, the memory from which we can only read but cannot write on it. This type of memory is non-volatile. The information is stored permanently in such memories during manufacture. A ROM stores such instruction as required to start computer when electricity is first turned on. This operation is referred to as bootstrap. Read-only memory chip are not only used in the computer but also in other electronic items like washing machine and microwave oven, and there are so many other devices also. Then coming to the different types of ROMs, which is MROM, which is masked RAM. The very first ROMs were hardwired devices that continued a pre-programmed set of data or instructions. These kind of ROMs are known as masked ROMs. It is inexpensive ROMs. Next is the programmable read-only memory, which are also called PROM. PROM is read-only memory that can be modified only once by a user. The user buys a blank PROM and enters the desired contents using PROM programmer inside the PROM chip. There are small fuses which are burnt open during programming. It can be programmed only once and is not erasable. So these are mainly used in the BIOS memory storages. And the second EEPROM, erasable programmable read-only memory. The EEPROM can be erased by exposing it to ultraviolet light for a duration of up to 40 minutes. Usually, an EEPROM eraser achieves this function during programming an electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because the charge has no leakage path. For erasing this charge, ultraviolet light is passed through a quartz crystal window that is placed in the lid of a chip. This exposure to ultraviolet light dissipates the charge. During normal use, the quartz lid is sealed with a sticker. The next ROM that we are going to discuss is E-square ROM, or electrically erasable and programmable read-only memory. The EEPROM is programmed and erased electrically. It can be erased and reprogrammed about 10,000 times. Both erasing and programming takes about 4 to 10 milliseconds. In EEPROM, any location can be selectively erased and programmed. EEPROMs can be erased on one byte at a time rather than erasing the entire chip. Hence, the process of reprogramming is flexible but slow. Classification on the basis of access. Serial access memory, direct access memory, and cache memory. Now, let us discuss about the various memories again. There are three types: serial access memory, sequential access. How we access the memory are the three types: serial, direct, and cache. Sequential access means the system must search the storage device from the beginning of the memory address until it finds the required piece of data. Memory device which supports such access is called a sequential access memory or serial access memory. Magnetic tape is an example of serial access memory. Direct access memory. Direct access memory or random access memory refers to conditions in which a system can go directly to the information that the user wants. Memory device which supports such access is called a direct access memory. Magnetic disks, optical disks are examples of direct access memory. Cache memory. Cache memory is a very high-speed semiconductor memory which can speed up CPU. It acts as a buffer between the CPU and main memory. It is used to hold those parts of data and program which are most frequently used by CPU. The parts of data and programs are transferred from disk to cache memory by operating system, from where CPU can access them. Then discussing about the program logic device. Program logic devices are the integrated circuits. They contain array of AND gates and another array of data. There are three kinds of PLDs based on the types of arrays which has programmable feature. The programmable logic devices, PLDs, are the integrated circuits. They contain an array of AND gates and another array of OR gates. There are three kinds of PLDs based on the type of arrays, which has programmable features. Program read-only memory, programmable array logic, programmable logic array. The process of entering the information into these devices is known as programming. Basically, users can program these devices or ICs electrically in order to implement the Boolean function based on the requirements. Here, the term programming refers to hardware programming but not software programming. The read-only memory is a memory device which stores binary information permanently. That means we cannot change that storage information by any means later. If the ROM has programmable feature, then it is called programmable ROM, that is pre-PROM. The user has the flexibility to program the basic information electrically once by using PROM programmer. PROM is a programmable logic device that has fixed AND array and programmable OR array. This is a block diagram of PROM is shown in the following figure. You have n inputs, fixed AND array, and again it's connected a programmable OR array. Then we have m inputs. Here the inputs of AND gates are not of programmable type, so we have to generate 2 to the power of n product terms by using 2 to the power of n AND gates having n inputs each. We can implement these product terms by using n into 2 to the power of n decoder. So this decoder generates n minterms. Here, the inputs of OR gates are programmable. That means we can program any number of required product terms. Since all the outputs of AND gates are applied as inputs to each OR gate, therefore, the outputs of PROM will be in the form of sum of minterms. For example, let us implement the following Boolean function using PROM. A is some function A, the variables x, y, and z is equal to summation m567, and B, another function x, y, z are the various variables, three variable inputs, which is equal to summation m of 3, 5, 6, 7. These are the outputs of the Boolean functions. Now, the given two functions are in sum of minterms form, and each function is having three variables x, y, and z. So we require a 3 to 8 decoder and two programmable OR gates for producing these two functions. The corresponding PROM is shown in the following figure. Here, In the example, the first example, it is 567 is given. So that 567 is connected to the OR gate and will be connected to the output. Whereas in the example 2, it is connected 3567, that is OR gate B is connected. Here 3 to 8 decoder generates 8 minterms. The two programmable OR gate having the access of all these minterms, but only the required minterms are programmed in order to produce the respective Boolean functions by each OR gate. The symbol X is used for programmable connections. Now coming to the programmable array logic, PAL is programmable logic device that has programmable AND array and fixed OR. The advantage of PAL is that we can generate only the required product terms of Boolean functions instead of generating all the minterms by using programmable AND gates. Here you have programmable AND inputs and OR array. Here the inputs of AND gates are programmable. That means each AND gate has both normal and complemented inputs of variables. So based on the requirements, we can program any of those inputs. So we can generate only the required product terms by using these AND gates. Here, the inputs of OR gates are not of programmable type. So the number of inputs to each OR gate will be a fixed type. Hence, applying those required product terms to each OR gate as inputs. Therefore, the outputs of PAL will be in the form of sum of products form. Example, let us implement the following Boolean functions using PAL. That program, that is A is equal to xy plus x z prime, z dash. That is the complement of z bar, let us say. B is equal to x y bar plus y z bar. Now, the two given functions are hereby two product terms present in each Boolean function. So we require 4 programmable AND gates and 2 fixed OR gates for producing those two functions. The corresponding PAL is shown in the following figure. So X and Y, and here X and it's connected to Y bar, Z bar, and another one is connected to X and Y bar, and the fourth one is connected to Y and Z bar. This is the AND gates are connected, and then again it's connected to OR gate array. The programmable AND gates have the access of both normal and complemented inputs of variables. In the above figure, the inputs X, X bar, Y, Y bar, Z and Z bar are available at the inputs of each AND gate. So program only the required literals in order to generate one product term by each AND gate. The symbol X is used for programmable connections. Here, the inputs of OR gates are of fixed type, so the necessary product terms are connected to inputs of each OR gate so that the OR gate produce the respective Boolean functions. The symbol is used for fixed connections. Logic array, block diagram of PLA. PLA programmable logic device that has both programmable AND array and programmable OR array. both flexible PLDs. Here the inputs of AND gates are programmable. That means each AND gate has both normal and complemented inputs of variables. So based on the requirement, we can program any of those inputs. So we can generate only the required product terms by using these AND gates. Here, the inputs of OR gates are also programmable. So we can program any number of required product terms. Since all the outputs of AND gates are applied as inputs to each OR gate. Therefore, the output of PAL will be in the form of sum of products form. The example, let us implement the following Boolean functions using PLA. A is equal to xy plus xz bar and B is equal to xy bar plus yz plus xz bar. These are the sum of products form. The given two functions are in sum of products form. The number of product terms present in the given Boolean functions A and B are 2 and 3 respectively. One product term z bar x is common in each function. So require 4 programmable AND gates and 2 programmable OR gates for producing those two functions. The corresponding PLA is shown in the following figure. This is the example for the first xy and then x and z bar and x and y bar and y and z. It's connected to PLD. The programmable AND gates have the access of both normal and complemented inputs of variables. In the above figure, the inputs x bar, y bar, z bar are available at the inputs of each AND gate. So, program only the required literals in order to generate one product term by each AND gate. All these product terms are available at the inputs of each programmable OR gate, but only program the required product terms in order to produce the respective Boolean functions by each OR gate. The symbol X is used for programmable connections. The other type of array, field programmable gate array. The field programmable gate array or FPGA is a programmable logic device that can have its internal configuration set by software or as it is termed firmware. This enables the FPGA functionality to be updated or even totally changed as required. Because the FPGA firmware is updated when it is in circuit. The FPGA programmable logic components or logic blocks, as they are known, may consist of anything from logic gates through to memory elements or blocks of memories, or almost any element. This provides a considerable degree of flexibility. The great advantage of the FPGA is that the chip is completely programmable and can be reprogrammed. In this way, it becomes a large logic circuit that can be configured accordingly to a design. But if changes are required, it can be reprogrammed with an update. Thus, if circuit card or board is manufactured and contains an FPGA as part of the circuit, this is programmed during the manufacturing process, but can later be reprogrammed to reflect any changes. Thus, it is programmable in the field, and in fact, this gives rise to its name. It contains 10,000 logic gates with programmable interconnection. Programmable interconnections are available for users or designers to perform given functions easily. A typical model FPGA chip is shown in the given figure. There are I/O blocks which are designed and numbered according to function. For each module of logic level composition, there are CLBs, configurable logic blocks. CLB performs the logic operation given to the module. The interconnection between CLB and I/O input-output blocks are made with the help of horizontal routing channels, vertical routing channels, and PSM, programmable multiplexers. The number of CLB it contains only decides the complexity of FPGA. The functionality of CLBs and PSM are designed by VHDL or any other hardware descriptive language. After programming, CLB and PSM are placed on chip and connected with each other with routing channels. Typical FPGA chip model, which is logic block it has, and that's it. So here I'm going to stop for today.